Hello and welcome back to Engineers Olympiad, where learning meets success. We're going to start the new subject of civil engineering, that is bridge engineering. So let's begin. Bridge engineering is one of the most fascinating fields in civil engineering, calling for expertise in many areas, which range from surveying to statistics, runoff calculations to rubble masonry, steel to structural concrete, and materials to modern methods of construction. Hence, a successful bridge engineer must have an expertise in various areas which range from surveying to statistics, from runoff calculations to rubble masonry, from steel to structural concrete, and from materials to modern methods of construction. A successful bridge engineer has to have an appreciation of both aesthetics and economics, besides ability in analysis and dexterity in design. Such is the wonderful and fascinating field of bridge engineering. Before moving any further, let's study about the definition of a bridge. Let me rub it first. Definition of a bridge. What is a bridge? A bridge is a structure providing passage or an obstacle without closing the way beneath. So a bridge is a structure which provides passage over an obstacle but without closing the way beneath. Okay? Without closing the way beneath. A bridge is a structure providing passage or an obstacle without closing the way beneath. And this required passage may be for a road, for a railway, or pedestrians, or a canal, or even for a pipeline, etc. And the obstacle which needs to be crossed over, it may be a river, even a road, a railway, or even a valley. Okay? So a bridge is a structure providing passage or an obstacle without closing the way beneath. And this passage may be required for a road, a railway, a pedestrian, a canal, or a pipeline. And the obstacle that needs to be crossed, it may be a river, even a road, a railway, or a valley. Bridges are remarkable feats of engineering composed of several parts that work in harmony to provide vital connections across obstacles such as rivers, valleys, or even roadways. And these structures are essential for transportation and infrastructure, and they consist of various components, each playing a unique role in ensuring bridges' stability, load bearing capacity, and functionality. Let me rub it first. From superstructure of a bridge that supports the roadway to the substructure of a bridge that anchors it to the ground, or the foundation of that particular bridge that transmits load to the bearing strata different parts of a bridge collectively form an intricate system that allows people and vehicles to traverse otherwise impassable terrains. All right. And this bridge, it serves as a vital link. Bridges serve as a vital link, providing passage over rivers, valleys, or other impediments. And it's a testament to allowing the smooth flow of people or vehicles from one side to the other. So this was about the definition of bridge and importance of bridge. Before moving any further and studying about components of a bridge, we have to study one very important thing, that is span of a bridge. So let me rub it first. Span of a bridge. In the field of bridge engineering, one of the most fundamental terms is this, span. Because the span of a bridge is most fundamental term and it plays a crucial role in design, engineering and overall performance of a bridge. What is the span? The span of a bridge refers to the distance between two supporting structures such as piers and abutments that hold up the bridge deck. So span of a bridge refers to the distance between two supporting structures such as piers and abutments that hold up the bridge deck. And as already discussed, this span plays a crucial role in the design, engineering, and overall performance of a bridge. And understanding the span definition in bridge construction is essential for engineers, architects, and construction professionals as it influences not only the bridge's structure but its functionality, its cost, and durability as well. Okay, let me drop it first and draw a diagram to illustrate the concept of a span in a bridge. If this is the bridge deck, and this is one pier, and this is the other pier, then the center to center distance this is known as the span in a bridge. All right, this is the span. Since this is the end, here will be abutment, so this will be end span. This is also one of the end spans. And the total distance, this span plus both of the end spans, the total distance is length of the bridge, total length of the bridge. All right. So if I may have to illustrate it in simple terms, the span of a bridge is a measurement of the distance between two supports that bear the load of the bridge, because these piers bear the load of the decking of the bridge. All right. And the span is typically measured from the center of one support to the center of the next support, that is center to center distance between two adjacent piers or abutments. All right. And for example, this differs from various bridges. For instance, if I take the case of a suspension bridge, the span is typically measured from center of one support to the center of the next support, but it depends on the type of bridge and varies from one bridge to other. And in case of a suspension bridges, the span is measured between towers that hold the cables, two adjacent towers that hold up the cables. And in case of a beam bridge, the span is the distance between two piers that I already showed here. It's the distance between two piers or supports beneath that hold up the bridge deck. This is the deck of the bridge. Okay, so summarizing it further, in simplest of terms, I may say that span is the center to center distance between two adjacent towers or pylons or piers or supports of a bridge. The center to center distance between two adjacent towers, pylons, piers, or supports, depending upon the type of the bridge, that distance is known as the span of a bridge. All right, so this was about the span, which is the most fundamental term used in bridge engineering. Moving on, let's study about the components of a bridge. Components of a bridge. The main components of a bridge are, first there is decking, which consists of deck slab, girders, trusses, etc. Then we have bearings for the decking. Bearings for the decking. Then we have abutments and piers. Abutments and piers. Then foundation for the abutments and piers. Foundation for the abutments and piers. River training works. River training works. Like revetment for slopes, and aprons at riverbed level, etc. There are more, but let me drop it first. So the components of a bridge are decking, which consists of a deck slab, girders, trusses, etc., bearing for the decking, abutments and piers, foundations for the abutments and piers, and river training works like revetment for slopes and aprons at the bed level, etc. We have more. Let me drop it first. And we have approaches to the bridge to connect it to the roads on either side. So 6 is we have approaches to the bridge, and their function is to connect it to the road on both of the sides. Okay. Then we have handrails, parapets, guard stones, etc. So these are the various components of a bridge. I may repeat it again. Decking, which consists of deck slab, girders, trusses, etc. Bearings for the decking, abutments and piers, foundation for the abutments and piers, river training works like revetment for slopes and aprons at the riverbed level, approaches to the bridge to connect it to the roads on either side, and handrails, parapets, and guard stones, etc. So broadly speaking, there are 3 main components of a bridge. First one is the superstructure. Second one is the foundation. And third one is the substructure. Broadly speaking, there are 3 main components of a bridge: superstructure, foundation, and substructure. Superstructure, the components above the level of bearings are grouped as superstructure. Foundation, the portion below the bed level of river, it's known as foundation. And substructure is that part, all those components which are below bearing, below the level of bearing, but above the level of foundation. They are known as, those components form the substructure. I have one typical drawing of a bridge. You can see it. I have one more. So this is superstructure, this is substructure, and this is foundation. We have many components of a bridge as told. Decking, this is the decking. Then we have bearings, these are the bearings. Then abutments and piers, this is the abutment. The end supports and intermediate supports are known as piers. Then I have the foundation, this is the foundation which is below the bed level of that particular river over which we are building that bridge. Then we have the river training works, which is here, pitching for the embankment slopes and aprons, etc. Then hand rails, parapet, etc. This is also shown. So broadly, I categorize the components of a bridge in three parts: the superstructure, the foundation, and the substructure. Wherein I told you, this is the superstructure, that the portion below superstructure, that the components, all those components which are above the level of this bearing, all those components which are above the level of the bearings are grouped as or termed as superstructure. Then foundation, which is below the bed, this is the bed level of the river, and all that portion which is below the bed level of a river, that forms foundation. And all those components which are below the level of the bearing but are above the level of the bed level of that particular river over which we are building that bridge, that form the substructure. All right, so this is foundation, this is substructure, and this is superstructure. In superstructure, we have decking, we have handrails, parapets, curb, approach slabs, etc. Then we have bearings in substructure. We have bearings, we have abutments, we have piers, and below the bed level of the river, we have the foundation. So this is the typical elevation of a bridge structure, and these are the components of a bridge. Now let's study them in detail. Let me rub it first. So there are essentially three main components of a bridge: superstructure, a foundation, and a substructure. All those components which lie above the level of bearings are known as superstructure. That portion of the bridge which lies below the bed level of the river is known as foundation. And those components which fall below the level of bearings but above the level of foundation are grouped as substructure. Now let's study about them in some detail. First, we'll study about the deck slab or deck. In figure, you can see this is the deck slab. This is the deck slab, right? In this figure also, I'll show you. This is the deck slab. All right, this portion is the deck slab. What is deck slab? Deck is that part of the bridge that accommodates and carries all traffic, making it a critical component for the safe passage of vehicles and pedestrians. So it is that part of the bridge, that part of the bridge that accommodates and carries all traffic, be it vehicular traffic or pedestrian traffic, making it a critical component for the safe passage of both vehicles and pedestrians. Okay, so the deck slab or the deck is that part of the bridge which actually accommodates and carries all that traffic, making it a critical component for the safe passage of vehicles and pedestrians. Then let's study about girders or beams. Girder or beams are integral parts of the superstructure and are responsible for bearing the deck. These bear the deck, all the load that comes on the deck. And these structural elements bend along the span and provide essential support for the deck. They provide essential support for the deck. Okay, So girder or beams are integral parts of the superstructure and are responsible for bearing the deck, and these structural elements bend along the span and provide essential support for the deck. Let me show you in the diagram. See, this is the deck slab and these are the girders. This is a cross girder and this is a longitudinal girder. All right. So they are responsible for bearing the deck and provide essential support for the deck. Moving on, let's study about bearings. What are bearings in a bridge? Bearings. Bearings are provided in bridges to transmit the load from superstructure to substructure in such a manner that the bearing stresses induced in the substructure are within permissible limits. So these bearings are provided in bridges to transmit load from superstructure to substructure in such a manner that the bearing stresses induced in the substructure are within permissible limits. Bearing stresses, all right. Bearings are provided in bridges to transmit load from superstructure to substructure, but in such a manner that the bearing stresses induced in the substructure are within permissible limits. And these bearings should also accommodate certain relative movements between the superstructure and the substructure. They have to accommodate certain relative moments between substructure and the superstructure. So bearings are provided in bridges to transmit the load from superstructure to substructure in such a manner that the bearing stresses induced in the substructure are within the permissible limits, and they should also accommodate certain relative movements between the superstructure and the substructure. And these bearings are provided at the top of the piers and the abutments. I will show you in the diagram. They are provided at the top of the abutments or the piers. This is the bearing pad, this is the bearing pad, and this is the bearing pad. In this diagram you can also see this is the bearing, this is the bearing, and these are provided at the top of abutments and piers. Let me drop it first. They are provided at the top of piers and abutments. All right. Thus, the components which are provided over the supports of a bridge to accommodate the changes in the main girders, that changes may be due to deflection, they may be due to temperature, or vertical movement due to sinking of the supports, or shrinkage, or pre-stressing, or maybe creep, etc. and to transmit the load from the superstructure to substructure in such a manner that the bearing stresses induced in the substructure are within permissible limits are known as bearings, and they typically provide a resting surface between bridge piers and the bridge deck. And bridge deck. You can see in the figure. These bearings are providing a resting surface between the bridge piers and the bridge deck. All right. Here you can also see these are the bearings, and they are providing a resting surface between the bridge deck and the bridge piers or abutments. And as already discussed, they are there to transmit the load from the superstructure to substructure in such a manner that the bearing stresses induced in the substructure are within the permissible limits, and besides that they have to also accommodate certain relative movements between the superstructure and substructure. When I told you that these changes or these relative movements may be due in main girders of the decking may be due to deflection, temperature, vertical movements due to sinking of the supports, or shrinkage, pre-stressing, creep, etc. All right. And as already discussed, they provide the resting surface between the bridge piers and the bridge deck and are always provided at the top of piers and abutments. We have two types of bearings. Let us study about that as well. We have two types of the bearings. First one is fixed bearing, and the second one is expansion bearing. We have two types of bearings, fixed bearing and the expansion bearing. Fixed bearings allow rotation. They allow rotation, but they restrict translation. Fixed bearings allow rotation, but they restrict translation, thus preventing expansion. They prevent expansion, but they allow rotation, whereas these expansion bearings, they allow both rotation and longitudinal translation. They allow both rotation as well as longitudinal translation. That is, they allow both horizontal movements and rotations. All right, so this was about the types of bearing, fixed bearings and expansion bearings. Whereas fixed bearings, they allow rotation, but they restrict translation, hence they prevent expansion. Whereas expansion bearings, they allow both rotation and longitudinal translation, that is, they allow both horizontal movements and rotations. Bearings form an important part of the bridge and are included among the most highly stressed elements in a bridge. They call for care in design, skill in execution, and regular maintenance. Faulty design or malfunctioning of the bearings have often contributed to the collapse of the bridges. And as we know, let me drop it first. Useful life of a bearing. Useful life of a bearing is generally less than the service life of the bridge. useful life of a bearing is generally less than the service life of the bridge. Hence, specific provisions should be made in the design of every new bridge for the bearing to be replaced by temporary jacking of the deck so as to permit a replacement by which we can change the bearings. Because useful life of a bearing is generally less than the service life of a bridge. Alright, if such a need arises, there must be some provision by which we can go for replacements of the bearing by way of temporary jacking of the deck. Alright, and the type of the bearing to be used or selected in a particular bridge depends upon the type of structure, the type of the supports, and also the span length. What type of bearing we are going to use for any particular bridge, it depends upon the type of superstructure, the type of supports, and also the span length of that particular bridge. Then we go on selecting the suitable type of bearings for that particular bridge. All right. Elastomeric bridge bearings are the most common type of bearings we use in a bridge. Elastomeric bridge bearings. These are the most popular type of bridge bearings which we use nowadays, and they are made of rubber and do not have any moving parts because rubber itself allows movements in the bridge. Okay, so this was about bearings of a bridge. Going on, let's move further and study about the pier and abutment caps. Pier and abutment caps. The pier or abutment caps, also known as bed block or bridge seat, pier or abutment caps are also known as bed block or bridge seat, and it is the reinforced concrete bed block resting over the top of the pier or the abutment. It's a reinforced concrete bed block resting over top of piers or abutments. So what is a pier and abutment cap? These are also known as bed blocks or bridge seat, and these are essentially reinforced concrete bed block which rests over the top of piers and abutments. In figure you can see over here. These are the pier or abutment caps, and this is a reinforced concrete bed block which rests over the top of piers or abutments, and it's also known as the pier cap is also known as bed block or bridge seat. All right, so this is essentially a reinforced concrete bed block which rests over the top of the piers or abutments. Now, what is their function? It provides the immediate bearing surface for the support of the superstructure at the pier or abutment location and disperses the strip loads from the bearings to the substructure more evenly. Let me write it down over here. All right, so we're studying about the pier or the abutment caps. And what is their function? They provide immediate bearing surface for the support of the superstructure at the pier or abutment location and disperses strip loads from the bearings to the substructure more evenly. In diagram you can see this is the deck slab, these are the bearings, this is the bed block or abutment cap or bridge seat, and their role is essentially that it provides an immediate bearing surface for the strip loads from the superstructure to disperse more evenly in the substructure. So this is about the role or the function of the pier or abutment cap. All right, and this pier cap should cover the entire area of the top of the pier. It should cover the entire area of the top of the pier or the abutment. All right, and besides that it should also project 75 mm beyond the pier dimensions. If this is a pier, let's suppose this is a pier and this is the bed block, reinforced concrete block, but it should also project, there must be some offset of about 75 mm beyond the dimensions of the pier or abutment, and this is essentially to prevent rainwater from dripping over the sides of the pier or abutment. Let me illustrate it once again, that the pier cap should cover the entire area of the top of the pier and should project 75 mm beyond the pier dimension, and this offset prevents rainwater from dripping down the sides and ends of the pier, and this also improves the appearance of the pier. Keeping an offset also improves appearance of the pier. And the top of the pier cap, except at bearing, should have suitable slope towards outside. Okay, but except at the position where there are bearings, this pier cap or bed block or bridge seat should have suitable slope towards outside. So this was about the pier and abutment caps. Moving on, let's study about abutments. Abutments. An abutment is the substructure which supports one terminus or one end of the superstructure of a bridge and at the same time literally supports the embankment. It is that part of the structure of a bridge that supports one terminus or one end of superstructure, and at the same time it has another function that it laterally supports the embankment as well, and that embankment supports or is an approach to the bridge. So here in the diagram you can see that abutment, this is an abutment, and abutment is that part of the substructure which supports one terminus or one end of the superstructure, and at the same time it literally supports the embankment, all right, which serves as a approach to that particular bridge. And for a river bridge, the abutment also protects the embankment from the scour of the stream. You must know that in case of a river bridge, abutment also supports, also prevents the embankment from the scour of the stream. So that part of the substructure which supports one terminus or one end of the superstructure, and besides that also literally supports the embankment, is known as the abutment or the end support of the bridge. And in case of a river bridge, these abutments also prevent the embankment from the scour of the stream. And these bridge abutments can be made of masonry. Let me drop it first. Abutments can be made of masonry or plain concrete, or they may also be made of reinforced concrete. All right. So abutments can be made of masonry, it can be made of plain concrete or reinforced concrete as well. And this abutment generally consists of the following three distinct structural elements. Let's study about that. Abutments consist of three distinct structural elements. What are these? It is composed of three distinct structural elements. Let's study about that. The first one is the breast wall. The second one is the wing wall. And the third one is the back wall or the dirt wall. Back wall or dirt wall. So abutment essentially has three distinct structural elements. First one being the breast wall, second one is wing wall, and the third one is the back wall or dirt wall. Now let's study about them. What is the breast wall? Breast wall is that particular component or a structural element of an abutment which directly supports the dead and live loads of the superstructure. It directly supports both dead and the live loads from the superstructure. Dead and live loads of superstructure. Breast wall is that wall which directly supports the dead and the live loads of the superstructure and retains the filling of the embankment on its rear side. Let me drop it first and let's study them individually. This is about the breast wall. There are essentially three structural distinct components of an abutment: breast wall, wing wall, and dirt wall. We're studying about breast wall. It is that particular element which directly supports the dead and live loads of the superstructure, and besides that it retains filling. It retains the filling of the embankment on its rear side or the back side. On its rear side. Then we have the wing wall. Wing wall acts as extensions of the breast wall. These are the extensions of breast wall. These are the extensions of the breast wall in retaining the fill. But they do not take any loads from the superstructure. All right. They do not take any loads from the superstructure though. So the breast wall is that component which directly supports the dead and live loads of the superstructure. Besides that, it also retains the filling of the embankment on its rear side or the back side. These wing walls are the extensions of the breast wall in retaining the fill, but they do not take any loads, be it dead loads or the live loads from the superstructure. The third structural element of an abutment is back wall or dirt wall. Let's study about that. Back wall, also known as dirt wall, it is a small retaining wall just behind the bridge seat. What is a bridge seat? The bed block or the reinforced concrete block or abutment. That is known as a bridge seat. Already studied. So small retaining wall just behind the bridge seat is known as a dirt wall, and its function is that it prevents the flow of backfill material. It prevents the flow of backfill material from fill to bridge seat. All right, so this was about the three distinct structural elements of an abutment: the breast wall, the wing wall, and the back wall or the dirt wall. I'll show you here in the diagram. So these are the abutments. This is the approach of a bridge. This is a bridge. This is its carriageway. This is the abutment. It has three distinct structural elements. This one is the breast wall, which has two functions: that it takes both dead as well as live loads from the superstructure, and besides that, it also retains the fill on its rear side or the back side. And these are the wing walls. Their function, they act as extensions of the breast wall in retaining the fill. They retain the fill of the backment, the backfill material, but they do not take any loads from the superstructure. And just behind here, which is not shown in the diagram, there is a dirt wall which lies just beneath the bridge, just behind the bridge seat, and it's a small retaining wall that's known as a dirt wall or the back wall, and its function is that it prevents the material from flowing from the fill to the bridge seat. All right, this is bridge seat over here. So this is the breast wall. If I take the entire assembly of an abutment, this is the breast wall, these are the wing walls, and just behind the bridge seat here then there is a small retaining wall which is known as a dirt wall, whose function is to prevent the flow of material from the fill to the bridge seat. This was about abutment. The abutments are the end supports. They are the essential parts of the substructure, whose one terminus supports the superstructure and the other terminus has the function to serve to literally support the embankment, which serves as an approach to the bridge. Embankments serve as an approach to the bridge, to its carriageway, to its deck or to its deck slab. Moving on, piers. What are piers? Piers are structures located at the end of bridge spans, not at the end of bridge length. The supports which are at the end of the bridge length are known as abutments, but the structures which are located at the end of bridge span we already discussed. The supports which are located at the end of bridge spans are known as piers. All right, so those supports which are at the end of bridge spans, they are known as piers. Okay, and their function is twofold. Let me write it down. Function: piers are the structures located at the end of the bridge spans, and they are located at intermediate points between the end supports, which are known as the abutments. And the function of the pier is twofold. First one is to transfer the vertical loads to the foundation. Piers transfer vertical loads to foundation. Also, their second role is that they resist all the horizontal forces and the transverse forces acting on the bridge. They resist all horizontal and transverse forces that act on the bridge. So those supports which lie at the end of the bridge spans are known as piers, and they have two functions. The first one being that they transfer the vertical loads to the foundation, and they also resist all the horizontal and transverse forces acting on the bridge. Here you can see in the diagram, this is a pier. These are the end supports are known as abutments. Intermediate supports are known as piers, which are located at the end of the bridge spans, and the abutments are located at the end of the bridge length. All right, moving on. And these piers, these are one of the most visible components of a bridge, and they add to the aesthetic appearance of the bridges. You must note that. Moving on, let's study about foundation. The foundations are required to distribute the loads uniformly and equally to the bearing strata. That means the purpose of a foundation in a bridge is that it is required, or it equally and uniformly distributes all the load of the bridge down to the bearing strata or the ground beneath. Okay, and the design of the bridge foundations in general should conform to the standard specifications and code of practice for bridges as prescribed by the IRC Bridge Code, Indian Road Congress Bridge Code. All right, so this is the most important part or component of a bridge, whose function is to equally and uniformly distribute all the load of the bridge to the bearing strata below. All right, and the design should conform to the standard specifications as laid by the Indian Road Congress that has been given in their bridge code. Moving on. Handrails and parapets. Handrails and parapets. Parapets and handrails are provided on bridges as a protective measure. Handrails and parapets are provided on the bridges as a protective measure to keep bridge users from falling to the depth or the sides of the bridge. While these parapet walls would be adequate for culverts, parapets are adequate for culverts or small bridges for that matter. But in case of bridges which are long, we generally use handrails. And besides that, these handrails are prominently visible in the neighborhood, and their design should be such as to enhance the aesthetics of the bridge. All right, so this was about the handrails and the parapet. Here in diagram you can see this is the railing. In this diagram I'll also show you, these are the handrails and this is the parapet on the approach slab. All right, and their function is that they act as a protective measure to keep the bridge user safe from falling to the depth or the sides of the bridge. Moving on. Approach slab. Approach slab. What is approach slab? A reinforced concrete approach slab is usually provided on either side of a concrete bridge to function as a smooth transition between paved roadway and the riding surface of the bridge. Paved roadway and the riding surface of the bridge. So this approach slab is a reinforced concrete slab which is provided on either sides of a concrete bridge, and its function is that it acts as a smooth transition between the paved roadway and the riding surface of the bridge. All right, so this is about the approach slab, and the slab also serves to minimize the bumps to traffic. Bumps to traffic are also minimized by this slab, approach slab. All right, so this is about the approach slab. Let me show you here in the diagram. This is the approach slab, a reinforced concrete slab which usually acts as a smooth transition between the paved roadway and the riding surface of the bridge. All right, so this is approach slab. The last component, river training works. River training works. In case of major bridges across wide rivers, river training works are used. River bridges which are long and major and which are made over wide rivers, there we have to use river training works such as various river training works, guide buns. We have to use guide buns or maybe spurs or groins. And protection works to embankment, etc. All right, so in case of a major bridges which are made across wide rivers, river training works such as guide buns, spurs or groins, or various other protection works to embankments are required. And these guide buns are required. The first one, guide buns, they are provided to channel the flow of flood waters. They channel the flow of flood waters and they also protect embankment from or during floods. Okay, so guide buns channel the flow of flood waters and also provide protection to the embankments during the time of floods. These spurs or groins, they are provided for attracting, deflecting or repelling the flow of a channel. Let me rub it first and write it down over here. We need various river training works when we are building long bridges over wide rivers, and the various river training works provided are guide buns, spurs or groins, and various other embankment protection works. The first one, guide buns, are provided to channel the flow of flood waters. Besides that, they also provide protection during the time of floods. Spurs or groins, they are provided for training the river along a desired course. For training a river along a desired course by attracting, deflecting, or repelling the flow of a channel. All right, so these spurs or groins are provided for training the river along a desired course by attracting, deflecting or repelling the flow of a channel. And approach embankments also may require protection of slopes by way of pitching. We do slope protection of embankments by stone pitching. Besides that, we also provide apron or launching apron at the bed level. All right. So these are the various river training works that we have to go for while building long bridges or wide rivers. And these guide buns, they may be straight or elliptical. The usual shape is like this. All right, with a circular head and tail. And apron, which we studied, it's also known as launching apron. That is provided at the toe of the riverside slope for protection of toe from the scour of the stream. All right, so this was about the launching apron, the guide buns, the spars or the groins. Let me show you one diagram. If this is an embankment, this is the stone pitching. We pitch the slope of the embankment for its protection. And this is the launching apron. This is the HFL. This is the pitching. Right? So this is the stone pitching. This is the launching apron. This one. And this is the pitching. And as already discussed, an apron, which is also known as the launching apron, is provided at the toe side of the river slope for the protection of the toe against scour of the stream or the river. And stone pitching is also provided for the protection of the slope of the embankment. Protection of embankment slopes. So this was about various components of a bridge. With this, I conclude this video lecture. Thank you for watching.